All right, ideal gas law. This is a piece of cake. We talk about ideal gas law in this unit because we're back to thinking about moles of a substance. And if you remember from our previous gas law unit, we talked about the variables of gas that were pressure, volume, and temperature. But what we haven't taken into effect that we will here is the actual amount of gas. And a lot of people mistake the volume of a gas for the amount of gas, but that's not true. You can have a huge volume and almost no gas there, or you can have a really tiny volume and have a lot of gas there. So don't mistake volume for actual amount. Okay, so the thing to remember about standard gas, the ideal gas law, and by the way, this word ideal, we're not going to worry too much about that. That is sort of a set of behaviors that gases follow ideally in a sort of more hypothetical situation, but we're not going to think much about it. Just remember ideal gas law. So at standard temperature and pressure, that's 273 Kelvin and 1 atmosphere of pressure, or 101.3 kilopascals, or any of those other pressure constants that we're used to. At standard temperature and pressure, 1 mole of any gas will occupy the volume of 22.4 liters. All right, so here's the equation, and a few of these variables are familiar to you. Pressure, volume, and temperature are the ones that we know. For ideal gas law, I want your pressures to be in atmospheres, volume to be in liters, and temperature to be in Kelvin. That's really important that you adhere to those units. And that's important because we're going to use the R that we're going to define here as 0.0821. Those units have to be atmospheres, liters, and Kelvin. So that's a constant value we're going to use, and then N stands for the number of moles of a gas. So that's the amount of gas. All right, so here's where the R number comes from. So if we isolate the R variable, we would divide both sides by NT, and that's what this looks like here. So here's how that number is calculated. It's basically, so follow this. At standard temperature and pressure, that's 273 and 1 atmosphere of pressure, 1 mole of gas occupies 22.4 liters. Okay, and when you make the division of these numbers, the answer that pops out is the 0.0821. So there are other numbers you can use if you're dead set on your pressure being in kilopascals, for example, or whatever, but I think it's probably easier just to memorize this one number and then be good at converting any pressure unit that you might have into atmospheres, volume units into liters, and temperatures into Kelvin. Okay, so here we got to remember in this, to convert all those into liters, atmospheres, and Kelvin. And to get from Celsius to Kelvin, we just add 273 to any Celsius temperature. Okay, and then it's just an algebra equation. You're going to have 4 out of the 5 variables, so you're just solving for one of these variables. And so when you derive these equations, here they are, you're never going to solve for R. That's a constant value. So P is nRT over V, V is nRT over P, and N is PV over RT, and T is PV over NR. And with those 4 derived equations, you can solve for those 4 variables. So it's a pretty easy topic. I think the main thing is just making sure that you be sure to make your pressures atmosphere, your volume liters, and your temperature Kelvin. All righty.